Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So when we're asked to find the position, we're basically finding out what n is. And we're told that the sequence has a 39 in it, and we're finding the position of 39. So we're going to equal the nth term to the 39 and solve it. So we're going to put in our solving lines. And the first thing we're going to do is take away 15 from both sides, because we want n on its own. So we get 6n equals 39 take away 15, which is 24. Then we're going to divide 6 both sides. And so we get n equals 4. So 39 is the fourth term in the sequence. And you could write it out. You could put n equals 1, n equals 2, n equals 3. Just keep going till you get to 39. Or we can do the method we've just done, which is solving it. So we know that the mean is the sum of numbers over the amount. But in this question, we're actually given what the mean is. We're given that that is 29. We're also given the fact that there are 4 cards, so we're given the amount. So what we can do is just get our lines in and solve this. So what we're going to do is just times both sides by 4. So we're going to do 29 times 4, which is 116. And so we know that the sum of the numbers will be 116. So all we need to do is to find the 4th card, is get that 116 and just take away the numbers that we know. And when we do that, we get the answer 26. Now you can easily check this by adding up 37, 26, 27, and 26 again, and then dividing it by 4, and you will get 29. To find average speed, we do the total distance and we divide it by the total time. Now, in this question, we've got a bit of an issue because the question wants kilometers per hour, but the units are given to us in meters and minutes. So we just need to do some basic conversions. So 1080 meters is going to be 1.08 kilometers because there are 1,000 meters in a kilometer. So all we need to do is just divide the meters by 1,000. Minutes are a little bit trickier. To get from minutes to hours, all we need to do is divide by 60. And so when you divide that by 60, you get 0.2 hours. So we're going to put the kilometers at the top, 1.08, and we're going to divide that by the hours, which is 0.2. When you do that, you get 5.4. So our answer to 2 decimal places will be 5.40. Whenever you have a one-digit number or a 1 decimal place number, but you're asked to round it to 2 decimal places, you should really put a 0 on the end, which is what we've done. So here we can just draw in 2 extra lines, and we can see that it makes a right-angled triangle. And we're asked to find the length of the line segment AB. So we're asked to find what this length here is going to be. And we know what the other lengths are. We know that this is 2 and this is 3. So we're going to be using Pythagoras. And Pythagoras, we start by labelling the sides A, B and C must be the one that's opposite the right angle. And so we know Pythagoras is a squared plus b squared equals c squared. A is 2, b is 3, and 2 squared plus 3 squared is going to be 13. And then we're just going to solve that by square rooting both sides. So the square root of 13 is 3.605 blah blah blah. And it asks it to 2 decimal places, so it's going to be 3.61. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I go pick a point on my shape, and the bottom or the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So we notice with the simultaneous equations here, the coefficients of the x and the y's are different. So we need to make either the x's the same or the y's the same. I'm going to pick the y's. So we've got a plus 3 here and a plus 5 there. And so we need to find the lowest common multiple of 3 and 5, which is 15. So we need to make them both 15. So I'm going to write out the first equation again. And go get my lines in, because I'm going to times everything by 5 to make the coefficient of the y to be 15, because that's what we've decided to do. So we've got 10x plus 15y equals 40. And we're going to do exactly the same thing with the second equation. So we've got 3x plus 5y equals 14. Get our lines in. This time we're going to times everything by 3, because 5 times 3 is 15. So that's going to be 9x plus 15y equals, and then 14 times 3, which is 42. And so we're going to write the equations next to each other so we can do our simultaneous equation magic on them. So we've got 9x plus 15y equals 42. So we're going to draw our circles in, and remember simultaneous equations are always working downwards, so we draw these circles in just to show which direction we're going. And we're looking at the signs of the y, and the reason we're looking at the signs of the y is because the y is the one with the same coefficient. Now, with these signs, if they are both the same, we subtract. If they are both different, we add. Now looking at them, they are both pluses, so they are the same, so we are going to subtract. And we don't just subtract these, we subtract all of them. So we're going to do 10x take away 9x, which is just x, 15y take away 15y, which is nothing, which is good, that's what we want, and 40 take away 42, which is going to be minus 2. So x is equal to minus 2. But that is only one of the battles because we need to find out what y is. So we're going to substitute in that minus 2 into our first equation. So we've got 2 times minus 2 plus 3y equals 8. And we can get our lines in. So the first thing we're going to do is take away the minus 4. We're going to add 4 both sides because we've got a minus 4 here. So we're going to add 4 to both sides. So we've got 3y equals 12. And then the next thing is we're going to divide by 3 both sides to get y equals. So y equals 4. And we can check that by substituting it into the second equation and doing 3 times minus 2 plus 5 times 4, and that does equal 14. With these questions, it's normally easier to view these as two separate triangles. So we've got a small triangle here with 19 and 47. And what I'm going to do is I'm just going to move this out. And we've got a bigger triangle here. And we've got, well, we've got a bit of, we don't really know what any of the sides are just yet, but we can work them out. Okay, now we know that both of these triangles are similar, and the reason is they share an angle and the lengths at the bottom are parallel, so they will be similar, which means one's an enlargement of the other. And we are given some information in the question that the ratio of BC to DE is 1 to 6. So BC is this length here, and DE is this length here. So we're actually given the scale factor because we know that 1 times 6 is 6. So we know the scale factor is 6, and it's asking us to find length AD. And so the corresponding length to AD, which is this one here. So all we need to do is get that 47, times it by the scale factor, so times it by 6 to get to our value. So it's 282. So to do a cumulative frequency graph, we've got to first of all add a cumulative frequency column to our table. And cumulative frequency is just a running total. So we always start off with the first value, which is 10. Then we add the next value, so 10 plus 25 is 35. Then we add the next value, so that's going to be 50. Now, the cumulative frequency is the total amount so far. So for that first 10, for the frequency of cumulative frequency of 10, we're looking at everything up until the 20. So we plot it at the 20. So it'd be 20 and then 10. So this one here. Then the next one, the 35, is everything up until 40. So it would be here. And then the next one is everything up until 60. There we are. Now, next we want to join them up. Now you can draw them up with a curve, and in most exams you can actually join them up with straight lines. So something you can do is just join them up with, click the right one, straight lines like that. And on most exams that's absolutely fine. I'm going to join them up with a curve. There we go. Now technically I should really finish this off with a nice straight bit there, because there's just a constant 50 forevermore. Okay, so we're asked to find length AB, which is this length here. But I'm going to start just by renaming these letters, and I'm going to put this as a capital C and this as a capital A and a lowercase a over here. And the reason it being is that we're going to use this formula, which is area equals half AB sine C. And you can see that the angle C is a C in this formula, and so I've just changed it to a C here. And so we're looking for little a. We're not interested in little c or big B or big A. We're focused on, and we've got a little b here, we're focused on little b, little a and big C. The area is given to us in the question is 21.6. And we're looking for A, but B is 5 and C is 68. And so all we need to do here is rearrange all of this. And we're going to start just by working out what half times 5 times sine 68 is. And that's going to be 2.317 blah blah blah. That's times A. And then we're going to do a bit of solving, because if we divide both sides by that 2.317 blah blah blah, that'll give us what A is. So when we do that, we get 9.318 blah 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 equals A. So rounded to 2 decimal places, that's going to be 2.32. We're going to work out what the function fg is first. And functions actually queue up, so the first function will be g and then f. So we're going to first of all look at the function g, which will be 3x minus 3. And so it will be f of 3x minus 3. Okay, so all I've done there is fed in the x, which is inside the brackets, into the function g. And when you feed it in, it just becomes 3x minus 3. And it's even the same letter. Next, we want to feed in the 3x minus 3 into f of x, so where this x is here. So it's going to be 5 times 3x minus 3. Now, the question actually has this equal to 30 and asked us to solve it. So we're going to get that equal to 30, so 5 brackets 3x minus 3 equals 30. So we're going to get our solving lines in. Okay, we're going to start off by actually dividing the 5 both sides. We don't need to expand the brackets, we can actually just get rid of it by dividing the 5. And that will give us 6. I'm going to add 3 to both sides to get rid of that minus 3. And that will give us 3x on the left hand side and 9 on the right hand side. Then we're going to divide by 3 to get rid of that 3 before the x. So it just becomes x equals 3. So answer is 3. So we're given the equation of the line, which is y equals ka to the power of x. And we're given two coordinates. So we're looking at this first coordinate and put that into the equation. So y is 10 equals ka to the power of x, which is 1. And we're going to do the same with the other coordinate. So we've got 40 equals ka to the power of x, which is 3. Now look at what's happening to both sides. Here we're multiplying by a squared. So a to the power of 1 times a squared is a to the power of 3. And on this side we're multiplying by 4. So we have to be able to conclude that a squared equals 4. And if we square root both sides there, a must equal 2. So if a equals 2, we can just put that into the first equation here. So we've got 10 equals k times 2. And divide both sides by 2, and we get 5 equals k, or k equals 5. So our answers will be k equals 5 and a equals 2. Now check that works. So let's have a look at this second coordinate. And we're going to do y equals, and we're going to do 5 times 2 to the power of 3. 2 to the power of 3 is 8. 5 times 8 is 40. So we know that our equation works. When solving simultaneous equations, when you have the equations drawn graphically, the solutions are just where the two lines cross. So we've got a solution here and a solution here. So the first solution is that x is 0 when y is minus 3, and our second solution is that x is 3 when y equals 0. With this question, we're going to first of all have to find a length before we can find the length AF, and it does involve us thinking in 3D. What I find sometimes useful though is to draw kind of a 2D representation of the 3D. So I'm going to look at this triangle here, and I'm going to notice that I need to find length BF. That's going to be my objective at the start of this. So I'm just going to draw out this triangle again, but in 2D just to make it a bit easier. And BF is this length here, this is 6, and then this is 9. So we're going to use Pythagoras, so it will be sort of a squared plus b squared equals c squared, so it would be 6 squared plus 9 squared equals bf squared. 6 squared plus 9 squared is 117. And then we just get our solving bit in, just to square root both sides. And I can leave this as square root 117 for now. Okay, the actual length that we want is AF, which is this one here. And I'm going to create the right angle triangle using this bit here. So let's just draw that out. Now the top bit is AB, which is the same as the bottom. It's going to be 14. It's going to be the same as EF. Then the BF we've just found is root 117, and we're looking for AF. And this is the right angle. I didn't show the right angle on the other one, but it should be there. Okay, so we're going to use our a squared plus b squared equals c squared. And a squared is 14 squared plus square root of 117 squared equals AF squared. So 14 squared is going to be 196. Now root 117 squared is just going to get rid of the square root, so it's just going to be 117. And when you add them together you get 313. And again get our solving lines in. Square root both sides. And this time we're actually going to square root 313 because we need a decimal answer. So it would be 17.691 blah blah blah. It's equal to AF. And it says to 2 decimal places. So that's going to be 17.69 centimetres. We're going to first of all work out what the function f g of x is. And to do that, what we're going to do is just feed in the value of gx, the function, the kx plus 2. We're going to feed that in as the value of x in the f of x function. So instead of 4x, it'll be 4 lots of kx plus 2 and then plus 3. Now this says that fg, when 4 is put into it, it gets an answer of 187. So when 4 is put into it, well, let's put that 4 into it. So 4 brackets, and it's k times 4, so that's 4k, plus 2, plus 3. And it says that that will equal 187. So we've actually got something we can solve here. So I'm just going to rewrite that, but actually I might expand the brackets as well while I'm at it. So 4 times 4k is 16k, 4 times 2 is 8, plus 3 equals 187, and let's get our solving lines in. Okay, so first thing we're going to do is, well, we can add the 8 and the 3 actually while we're here. So 16k plus 11 equals 187. So we're going to take away that 11 from both sides. So we've got 16k equals 176. And then we can divide by 16 both sides. So we've got k equals 11. So answer is 11. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.